Very good evening, everyone.
Am I audible to all? Okay, perfect. So you guys are able to see my screen, the whiteboard? Okay, perfect.
Ma'am, if you scroll down towards the right, I see
Yeah,
something S1, S2, A, B, C, D. Oh, towards the right.
here?
Oh, okay, okay. The link that I have, it shows something else also.
No, I just removed that.
Okay.
Okay, so did anyone give this particular problem statement a shot? Like, did you tried it?
Yeah, I thought about it and couldn't get to it, how to do it.
Okay, Kishan, you also tried. So were you able to do it? No. Okay. It's not an issue that you guys are not able to do it. It's just that I wanted you to give it a thought so that when I'm explaining it in the class, it will be good. So let's begin. Number of ways we were talking, and you guys see that we can reach the via this way. Some should be 5. Why? 1, 2, 3, 4, 5, 6, 7, 8. The answer for this should be 8, right? If n is equals to 5.
Yeah,
Yeah,
but what I was thinking is that different combinations should add up to 5.
didn't get you.
So, since there are 5 stairs, whether I do 1 1 1 or 1 2 2 or any combination, the sum of the stairs should be 5. That was one
But
thing.
like it doesn't make any sense, Vishnu, that sum of stairs is equals to 5 because it is given as an input, right?
Yeah.
So
So I was
obviously the sum of all the numbers which I'm taking as a probable solution, it should be equals to 5. I can't take it more than that or less than that. Like this is a self-understood thing, right?
yeah, yeah.
Yeah. Okay. So we will look into this problem in from a different perspective. Okay. Like what I'm trying to say that here are your stairs. Let's suppose this is your topmost stair and like from below somewhere it is coming. If you are at this stair, I am naming this stair as the ith stair. So there are chances that you would have climbed up here from this stair, or there are chances that you would have climbed up to this stair from this particular stair. These are the two chances. Are there any other chances that you would have done? No. So the thing is, if you are on the ith stair, you can either climb there from the I minus 1th stair, or you can climb there from I minus 2th stair, right? If I am at I minus 1th stair, then again I have two choices. That is, I can climb it from I minus 2 stair, or I can climb it from I minus 3 stair. Same goes with this. I can climb it up here from I minus 3 stair, and I can climb up here from I minus 4 stair. Yes or no? If I'll do one more step, then you can see that I minus 2 stair I can go from I minus 3, or I can go there from I minus 4. Correct now? Same thing goes here. It will either come from I minus 4, or it will either come from I minus 5. Right? So you guys are able to see the way we are following, the things are getting repeated. That means you are having an overlapping sub problem over here. You can see you got your answer for I minus 3 over here, but still you are calculating it again at here and here also. So this is the reason your problem will get like if you try to do each and every step of this problem, your problem will get enhanced a lot. Okay, that means it will have a huge time complexity. So you noticed this or not? Everyone is able to get this? Yes. So I'll just quickly highlight few of the repeating problems I can see. So because of this, I can say that there exists an overlapping subproblem. And if I told you that if there exists an overlapping subproblem in any of the problem statement you get, then you can implement DP in it, right? Yes. Now, how to implement DP, we will see step by step for this particular question. Analysis is clear to everyone? Great. So whenever you are solving any DP question, the first thing you should do is to find out DP state. Okay. DP state in the sense that if you are at the ith stage, how can you get the answer for that ith stage? How can you reach that the result of the ith stage? Clear? Okay. So what should I write if I have to find out the answer for ith step, that how I reach the ith step? What should be the DP stage of this? It's basically you have to tell me some statement which will justify that, okay, if I do this, I will get my answer. What is DP of I? Kishan, which you are telling me, it's called as DP expression, not DP state. DP state here will be, you guys know that you have to find out the number of ways to reach your nth step, right? So here replace n with I. So it comes out to be the number of ways to reach ith step, right? That is your problem definition, right? Next is DP of I. Basically, you have to tell me DP expression. DP expression means now you have to tell me some mathematical expression based on which we are going to get our answer. Getting it? So now I'll just show you one diagram and you tell me what should be the DP expression. So you are at the source, you are at the starting point or source. I am taking a point A and I am taking a point B. Okay. I am assuming that if I have reached from here to here, I am at like DP of I minus 1. Basically, I am at the I minus 1th step. Next, I can assume that I am at DP of I minus 2th step. Why I am assuming only these two DP state? Because from this, I can directly reach to my destination I. Correct. How many ways you can reach from DP of I minus 1 to I? How many ways are there? One way, right? Perfect. How many ways are there you can reach from DP of I minus 2 to DP of I? Two ways, correct. One way is you can directly jump from DP of I minus 2 to here. That is one way. Next is you can go from DP of I minus 2 to DP of I minus 1. And then you can jump from DP of I minus 1 to destination, right? So this is also one way. Getting it? So from DP of I minus 2, You have 2 steps, right? So because of this, you have one way to reach from dp of I minus 1. But when we are at dp of I minus 2, whatever number of ways you have, it will be multiplied by 2, right? So this is your dp expression, correct? Yes. Now, again, coming to an analyzation point. When you are here at dp of I minus 1, don't you think dp of I minus 2 is already covered inside it? Like you have already calculated the ways to reach from dp of I minus 2 to dp of I minus 1. Isn't it covered in this particular sphere only? Yes. So basically, we are reiterating or recounting it again here. Getting it? So there is no need to do that. That means it should be removed. And hence, there is only one way to reach from dp of I minus 2 to here because the other way is already counted. Hence, instead of, wait, I'll just keep this as it is. I'll write here already counted. So your final expression will become dp of I minus 1 plus dp of I minus 2. Clear, guys? So this is known as dp expression. So first you identify what is your dp state, because dp state give you a clear idea that how to frame your dp expression. Okay, so first step is dp state, next is dp expression. Okay, now everyone understood this? Okay, perfect. So our next step is now base condition, where you should stop your program. What should be the base condition? Can anyone think and tell me what should be the base condition? Why I equals to 5? Like, do you know always that your I is gonna be 5? Correct. If someone told you, okay, tell me what will be the number of ways to climb the stairs if if n is equals to 0. Okay. Let me tell. If dp of I or dp of 0, someone asks you that find out when you are at 0th stair, what are the number of ways? What are the number of ways to reach the 0th stair? One way. What are the number of ways to reach one stair? One way. So these become your base conditions. Time complexity. How much time will you take to calculate your final answer? You're just adding two previous state to get the current state, right? So basically, if you have to go till n, it will take n time. The time complexity calculated here is, if you have to calculate one state, you can see just an addition. So it will take order of 1 time. Number of stairs totally you have, or number of states total you have, is n. So multiplied, you will get order of n. Any space complexity? DP table we are using, that is, we are storing our current states like previous two states. So it will be taking order of n time again, or space complexity is order of n. The extra space that you are using Basically in DP, we call it as a table size. So what is the table size? Don't worry, all these are not the pointers based on which interviewer give you 1 point. It's basically how to approach a DP problem. Okay. If you approach it via this way, it becomes a lot easy for you. Okay. Next is your answer. Where will you get your answer? You filled up your entire DP table. Where is your answer lying? Inside DP table, but at what position? You won't be iterating the DP table entirely, right? So if you have to find the number of ways to reach the nth stair, where will your answer be?
Ma'am, is the question how many ways by which it can reach?
Yeah.
Okay. So
What
since we,
were you understanding so far in this question?
yeah, up till space complexity, it's fine. Table size is n. This
No,
one.
we are not printing the ways to here. It's just the question is that you need to give the number of ways. It's not printing all the ways.
Okay.
Yes. Vishnu, do you have any question?
So number of ways, since for 5 it is 8, so using that n, it has to be some multiple of n. I don't know.
Guys, first is the question is answer. Your answer belongs to dp of n, okay? If dp of I give you the number of ways to reach ith step, so dp of n will give you number of ways to reach nth step, right? If your answer is at dp of n, that makes your table size to be n plus 1. Clear? You have to have your table size equals to n plus 1. Next is space optimization. So my question to you guys, you have only learned one DP problem so far with from me, but that is Fibonacci series. So can we do space optimization here, seeing the previous problem? Or do you find any resemblance of Fibonacci series in this specific problem? I am waiting. I'll wait for 2 minutes for your answer. Yes, it can be optimized. It's basically a problem statement which is similar to Fibonacci. Everything you can notice, it is like current state is sum of previous two states. Everything is same. And yes, the Fibonacci can be implemented here. So it is possible. Okay. And next is I don't think so. Okay, I need to tell you guys how to optimize it or write the code for this entire problem. Anyone needs the code for this? Okay. Okay, you want the code for this. Guys, it's the same code. The same Fibonacci code which you have written, you just copy paste it there. I told you it's same as Fibonacci series. Still you guys want it? I can copy and paste it here. Okay. So I'm going to pick up the next question now. If you guys are done with this. You have been given a dice. You have been given a dice. It's in standard six-sided dice. You will be given a sum n, like basically n input. You have to find out the number of ways you roll a dice to get sum equals to n. Clear? Basically, if I tell you let's suppose n you have been given as 5. Okay. Wait. N is given to you as 7. So what ways you can do it? So you can pick one. You will get, let's suppose you roll and you get 7. 1 1 all the times. 7 times 1. Next time you can get 1 1 1. Then you can switch it. Then probably you can get, I will write all possibilities. The next is you will have 1 1 1 1 3. Again same. Next you can have 1 1 1 4. Then 1 1 5. Then you can have 1 6. Further you can't go because 7 is the number which you don't have in a dice. This is just I showed you the permutation of ones. Next you can have 2 2 2 1 2 1 3 1. So like in this way there can be multiple possibilities, right? So you need to find out that the number of ways and then you need to return it. Clear everyone? Is the question clear to all? Okay. So basically, if I have to show you how it is happening, it's like if you have to get the sum of I, you can come from I minus 1th stage, that is you get 1, you rolled it here. You can come from I minus 2 state, You can come from I minus 3 state, I minus 4, I minus 5, and I minus 6. These are the states you can come from. So if you are at I minus 2 state, you can pick up 2 and you will get at I. You can get 3, you can get 4, 5, and 6. Clear? Then again, there is no need to tell you guys that if I split it up, if I have to reach I minus 3 state, I have to go there from I minus 4, I minus 5, I minus 6, I minus 7, I minus 8, and I minus 9. So you guys can clearly observe here that you have an overlapping existing I minus 4, I minus 4, I minus 5, I minus 5, I minus 6, and I minus 6. Similar to this, if you expand it more, you will get lots and lots of overlapping, which suggests that you can implement DP in this specific problem. Clear? Now, my question is, do you guys want to try it first? Because like it is very similar to the previous problem where you have to find the number of ways to climb up the stair. I explained it completely step by step. So would you guys like to give it a try today and then want the answer tomorrow, or should I explain it now only? Only one person is responding. Others, guys, I know that DP is a tough topic and don't hesitate to tell me that, okay, ma'am, tell the solution. The previous one, I didn't told the solution because you guys know that it's a copy of Fibonacci series. So there is no worth in writing the same solution like on the whiteboard. Not sure, but at least you can give it a try and then be sure. Okay. So I am not explaining this particular problem today. I'll take another question and then once you guys try it tomorrow or like come try, like after trying tomorrow, I'll explain it. Clear? Okay. So far only one thing we have seen in DP, that is if there exists overlapping subproblem, then we can implement DP. But there is one more property to identify if it is a DP problem or not, and that is known as optimal substructure. What is optimal substructure and like how it came into picture? Tomorrow when I'm explaining this dice problem, you will get it more idea, but right now I'm just trying to elaborate what it is. So right now, whenever I'm giving you some question, it is always like find out the number of ways to reach the stair, number of ways to get the sum. It's always the number of ways. But in optimal substructures, it's like you have number of ways, but you have to opt for the optimized solution amongst all the number of ways you have. Are you getting it? Like I say that let's suppose in this given problem, I tell you that every time you roll a dice, there is a cost associated with every roll. Okay. Let's suppose I tell you that if you roll and you get, just a minute, you roll and you get 1. Yeah, correct. We have one question in recursion magic square matrix, correct. So let's suppose of rolling 1, you are charged 3 rupees. If you roll and you get 2, then you are charged 8 rupees. If you roll the dice and you get 3, then it's 2. Similarly, 4, 6, 5, 10, and for 6, this is 5. Okay, don't miss it. For 6, it is 4. So now what happens in this question, I'll say, find out a way in which you have to spend the least, like you have to spend your money the least, and you have to get the sum. So in that case, you may be having multiple ways to reach the sum n, but you have to choose the way which cost you the minimum amount. Clear? Yes. And there comes optimal substructure into picture. Okay. So one thing is, if you are able to see overlapping subproblems, there exists the DP for sure. Next is optimal substructure you have to identify after identifying overlapping subproblems. Clear? Okay. So now I hope you got what optimal substructure I'm trying to say, like what it is. Perfect. Anyone having any questions in this? So you must got it. My one more question, that is, once you are done with your dice problem, finding out the number of ways, you have to find out the way in which you have to spend the least and you have to get the sum. That is the next problem to it. Clear? Okay, fine. So I'll just quickly write here a definition for it. It indicates for one subproblem, there may be multiple solutions. But you opt for the clear. So if you have understood the overlapping subproblem and optimal substructure, try to implement this. Okay, now I'm going to write in short what are all the DP stages which you need to follow. Like so far, there was no optimal substructure, right? But now there is. So furnace, you have to identify overlapping subproblems. Next is optimal substructure. I'm not writing the full form. You guys can write it. Third is DP state. Fourth one is DP expression. Fifth one is base condition. Sixth one is time complexity. Seventh one is table space. Eighth one is space complexity. Ninth one is where you will get your answer in the DP table. 10th is that whether you can optimize it or not. So space optimization. Clear, everyone? These 10 steps, if you follow in a DP DP problems becomes quite easy. And everyone who are thinking that DP is quite tough, let me tell you, it's just a way you approach a problem. It's not any, what should I say, some data structure implemented. It's just like how you approach a problem that defines if you know DP or not. That's it. So don't try to make it as a burden that, oh my God, what is DP? There are 10 steps we need to follow. It's just for your simplification, okay? Because if you follow these steps, DP will become quite easy for you. Clear, everyone? Okay, so should I explain one more problem for today, which you guys want to try at home, or is this much content sufficient for today? Okay. One more can be done, okay? So you have a floor. This is question number 4. The size of the floor is 5 is the, you can say, the length, and this much is its breadth, whatever you can say, length or breadth, I'm not sure. You have tiles or tile of size which is 1 and the length is 5. Okay, you can place this tile vertically or horizontally in to fill up this particular floor. Okay, so if I have to fill it, like, there should not be any extra tile which is going out of this floor. They should perfectly fit into this floor. Clear? So if I take, it should be 1, like I placed it vertically. So 1, 2, 3, 4, and 5. I'm assuming that my n is equals to 5. Next is, what can I do? 1, 2, 3, 4, 5. Is there any other way I can do it? For n equals to 5? No. Next is, if I take n equals to 8, then you can have 1, 2, 2, 3, 4, 5, and 1. Next, you can have, like similar, you can have permutations for this. Next is 1, 2, 3, 4, 5, 1, 2, 3. This much only, right? So 1, 2, 3, 4, 5. 5 number of ways you can do it. So it's the question that you have been given n. You have to find out the number of ways to arrange the tiles horizontally or vertically on the floor. Clear? So if this is clear, I won't like enhance it much, but this particular question can be done in several ways, or several variants can be made of this particular question. So Right now, you just try it. It's the most simplest version. And then I will tell you that, okay, what can be the complex versions that can be find out. Clear? Okay, so I have to stop the class over here because if I continue more, then it will be a too much burden for today. So you guys just go try these 2 questions today. If you are able to do it, great. If you're not, then we'll discuss it tomorrow in the class. Clear, everyone? Sorry, Kishan. Actually, I completely forgot it. I'll see it today. Okay. I'll definitely tell you that what's the problem in the left view you're facing in your code. Okay. Any other questions, guys? If you have any questions, we have 7 minutes left till it touches 9. Okay. Good night. Have a good day also. Okay, then if no one has any questions, I'll just close the call. Thank you for attending the class today. Bye-bye.